What is his question? He has configured 101 as the local preference here. The default is 100, we all know. Another thing is what he expects is because I have configured 101 here, to reach 5555, the traffic should leave this way. I'm not denying that. Look, that is what local preference should do. But what you fail to check in router 2 before questioning, what you have not analyzed properly, what you have failed to do is if router 1 needs to go where router 2. Did you check before setting local preference that there is a tie and there is two route for 555 coming from both router 3 and router 2? You have never checked it. You have never checked that router 2 is giving or not this 5555. When router 2 is not giving 5555, how can router 1 follow router 2 has got no meaning. If router 1 has got 5555 advertised, only then this 101 will come with that 555. Only then router 1 can follow this path. When router 1, when router 2 itself is not ready to give 555, when router 2 never spoke about 555 to router 1, when router 2 never spoke about 555 to router 1, how can your local preference 101 will impact 555 destination this path? That is why I said this lab should be properly done from zero level. Only when both router 3 and router 2 gives a route, and if it is going via router 3 which you don't like, by configuring local preference on router 2, you can force the traffic to go out via router 2. When you already get only one route advertisement from router 3, what is the point of me setting 101 for 5555? You cannot expect that. There should be a tie between these two. Why the route 555 is not advertised to router 1 from router 2? That was not your early question. Now, after I explain this, you come with new question. Again, the first question itself, I said it's too early. Fine. Anyhow, today you want to have your class in your own way. I'll take it in your own way. Why router 2 is not giving 5555 to router 1? Then you need to go and check, is router 4 giving? If that is also not having, go and check router 6, is it giving? If there is any trouble, go and troubleshoot it. Now, you see, I showed you commands to do wait and local preference. We added the wait attribute very next to the neighbor address. But the local preference, we used the command BGP, default local preference. That was the command. This origin, you don't have any commands to configure. If a network is locally advertised, you are going to see this. Now, with the topology that we were having, with this topology, that we were having, We were trying to understand the sequence. All right, the iteration. This is the point, the iteration is what we are trying to understand. We'll do a proper lab later. If I simply go through all this point without showing little lab in the middle, it will be boring stuff. That is why I made a two small demo yesterday. Our intention was not the attribute lab, just to show you, see where all it comes, see how the change happens, so that you will have an interest. You will also understand, oh yeah, I'm getting two roots. That part you never understood. The main reason for yesterday demo was, it was my customized demo. I was having both the roots. I want to straight away teach you weight and local preference, not the lab. So I kept the lab ready for you to understand these two things. That part you forgot. And you took something of your own trying to understand that part. Please try to follow the class. Go in trainer sequence so that you will not miss anything. Later when the BGP topic is over, then you can have your own sequence. Fine. In my topology, you saw both the next hop was valid to reach 555 or 444 or 666 or 777. Because there was a tie, we configured weight. And when I gave more weightage to this guy, it started going via this guy. When I gave no weightage for 555, it was going this way. For 444, it was going this way. We should go back to the yesterday's class and see the video. Next, when there is a tie-in weight, only then a local preference can be configured. So I removed the weight and I put local preference. When I put local preference here, I already had two options whether to go this way or this way. This was having route learned from both router 2 and router 3. You're having both the routes. It was going by default this way via router 3 to 5555 and 7777. Just to show how the local preference work, I took you here, I gave 101 here. As a result, including router 3, it started going this way. That is where we stopped yesterday. Now let us continue today. Next is origin. See, for this network, it will have 3, 2, 7, 6, 8 as a high weightage, automatically set. The reason is it is locally advertised. The next stop will be 0.0.0. Likewise for 2, 2, 2. In case if I advertise, if I have another loopback here with 7777, and I advertise that in BGP, it will have next stop 000 with 32768 as the weight. And now traffic will not go here. It will only use local. Why? Because weight is on the top. If weight is there, it won't go to the below attributes. If weight is a tiebreaker, it will never check any other attribute. When the origin is next stop 000, when the origin is local, the weight is automatically set. Next, the AS path. I repeat, our aim of this class and yesterday's class is to understand the attribute, not to understand any scenario or lab. understand the attribute sequence. Only that much. First, you should know this to do that. If you don't know this, it's of no use doing lab. Now, coming to this shortest AS path. Only if there is tie in this tree, it's going to check if any of the path has got shortest AS. For example, going this way to 666 is shorter than going the below path. Going the upper way is 1 and 2 hops, whereas the below way is 1, 2, 3 hops. So for this, what is important? You should first of all see both the routes available. You should see that first. Only then you can choose one and ignore the other. Right? So this is a condition. You should have a tie in all the above, and you should see the route with different AS path length. Different AS path length. The shortest AS path is going to be considered. Next is the origin code. Prefers the lowest origin code. What is origin? Origin explains how. AS path explains where. AS path shows from where it started and what all the AS path through which it is coming. Where and what path the route comes. Whereas the origin code tells how this particular network has been introduced into BGP. As we earlier discussed, like 4 classes ago before, I is preferred over E, and E is preferred over question mark, and you will never see E. Question mark is nothing but the redistributed one. I is nothing but internal to BGP. It is not IBGP or IGP. It is not interior gateway protocol or IBGP. Here, IGP means it is internal to this gateway protocol called BGP. It is internal to this protocol called BGP. It is advertised. It is advertised inside BGP. Prefers lowest origin code. Lower is preferred. Very important. See the symbol. Lower is preferred. If someone advertises, for example, let's say you have a network here 67.67.67.67, and here also you have a network 67.67.67.67. Here you advertise using network comment. Here you redistribute. Now which one R1 should prefer? It will prefer this because I is preferred over question mark. If you see, all the above attribute will be a tie. Same AS path, 1, 2 jump. Not same AS path, same number of hops. This way also 1, 2 jump to reach 67. But this is I, this is question mark. I is preferred over question mark. Lower is preferred. Is that understood? Did you understand this attribute 5? Okay. So attributes are read from top to bottom. When a tie break happens, it stops. It won't go further. And we are in attribute number 5. Only when the above 4 are tie, this 5 will be effective. Otherwise, don't dream. Don't dream that based on this attribute, the path will choose. You don't dream. That's not reality. That is not reality. If there is a shortest AS path, for example, you have redistributed here. Instead of there, let us redistribute here. 67, 67, 67, 67. I'm redistributing on this route. And here I'm advertising 67, 67, 67. Which one R1 will choose? This one only. Why? Only one jump, shortest AS path. Whereas here, 1, 2 jumps. There's a tie break here itself. It will not come to this origin code. It won't read this. It will not decide based on this. Based on this, it will do. Saying this is the best path to reach the 67. Is it clear? Right. Next is the MED. This MED will not come in multi-homing scenario. It will come only if you have dual homing scenario. In our topology that we are using to explain these things, you don't have any dual homing. You don't have dual homing. What is dual homing? If I will have two connections like this. Now router 5 has got two gateway from same AS to reach this 11111. Router 5, you need to see from this perspective, router 5 perspective. Now where is our test PC? Router 5. From router 5's angle to reach 11111, I have two paths. Which one to choose? You can decide that by configuring MED. See, before advertising 1.1.1.1, you can set MED. The default MED is 0. Router 2 is also advertising 0. Router 3 is also advertising 0. But you want router 5 to come via router 2 to reach 1111. I repeat, your preferred path is this. Then what you can do, you can set MED 10 here. MED lower is preferred. MED lower is preferred. So while advertising to eBGP, that's a very important point. MED is an attribute that is advertised to eBGP. The local preference or wait, all these things are within the autonomous system. MED is an attribute that can be advertised, not that can be, that is always advertised only to eBGP. Later, we will be learning something called community. I promised I'll go deep into BGP. Service provider track teaches community. That is also going to other autonomous system like MED. We'll talk about that community later when we go there. Now, MED lower is preferred. R5 decides to go via router 2 because of the MED 0. Fine, let's go to the next. In our topology, I said there is no chance of MED because we don't have this link. So don't try MED if you don't have a wire between router 2 and router 5. Again, even for MED, all the above should be a tie. Only then MED will be effective. Next, MED is used if you have dual homing. But what if it is multi-homing like ours? Like ours, it is multi-homed. Say, for example, this router. This router can reach to 6.6.6.6 this way because it is learning 6.6.6.6. So it can choose this path. Or it can also go this way because this guy is also advertising it. 6.6.6.6. Router 2 is also advertising it. Which one to choose? EBGP is preferred. EBGP is preferred over IBGP. So instead of going via router 2, it will choose to go via router 5. Why? EBGP is preferred over IBGP. EBGP is preferred over IBGP. Remember, for this you should have tie in all the above. Only then it comes here. Some I have seen, they know attribute, but they don't know the sequence. And they will say, hey, EBGP should be preferred over IBGP, man. Why it is not preferring? Because you don't have EBGP. Or you don't have a tie in the all above. So understand the sequence, mandatory. Sequence is important here. You see, I did not speak from this router's perspective when I'm talking about this attribute EBGP over IBGP, because I need a EBGP, I need an IBGP. So I took this router as an example to teach you this. So for everything, don't check from router 1. Oh, you will waste your time. Next. Prefers the path through the closest IGP neighbor. What does it mean? You see, only if there is a tie in all this, it comes here, which means what? Both can be an IBGP. See, if I have one EBGP, one IBGP, it will prefer EBGP. But if this is not a tiebreaker, which means what? Both can be a EBGP or both can be an IBGP. So now let us see first if both are IBGP. Say, for example, for this router, both are IBGP. And there is a tie in all this above. Which one router 1 will choose? It will see the OSPF cost. I repeat, router 1 BGP will see whether this IBGP neighbor is closest or this IBGP neighbor is closest. How it will know? It will check the cost. It will check the local routing protocol cost. If OSPF says cost is 11 here, cost is 6 here, R1 will say, I'll go this way. C prefers the path through the closest IGP. Is it clear? Cost அடுத்ததுக்கு போகும். If both the costs are same, it will go to the next attribute. Fine. Now, let us say here both are IBGP, so you are comparing cost. What if both are EBGP? Now, which EBGP gave the route early first? The oldest. Who gave me this one first? I will trust that neighbor. The oldest route. If two EBGPs are there, I don't have IBGP. Both are EBGP. In that case, who gave me this first? I'll prefer that. For example, for router 5, this guy is also EBGP, this guy is also EBGP. There is no IBGP. There is no IBGP. Now to reach 4.4.4.4, if there is tie in all these above, then router 5 will choose to go via the direction which gave the route first. Who gave route first? For example, I did not configure here. I configured this. Now this is the guy who is giving 4.4.4.4. Later I configured this, and now this guy is also giving 4.4.4. Now router 5 will say, this guy gave me very long back, old route. I'll choose to go this way. Old is always gold. Oldest route for EBGP path. Now, if there is tie in this also assume. Then only the other two you read it is. So, oldest route means the route which came very early. The neighbor who gave this route will be the preferred exit, preferred gateway, preferred direction, preferred path. Now, let us assume that this is very rare case. Let us assume both are at the same time. No routes are old. Both are EBGP. Both this EBGP router 3 as well as router 7 gave at the same time. Same, not even a fraction of millisecond difference. Assume. It's very rare. Assume. Only in that case, it prefers the neighbor's router ID, the router whose router ID is lower. Again, this will be the tiebreaker. There is no chance to go to the next one because the router ID will be definitely one lower than the other. There is no chance for two neighbors to have same router ID. So this is to be on the safer side in case if the router ID is misconfigured and it is same, which is not possible. In case, then the neighbor whose IP address is smaller, lower. This cannot be a tie at all. Can any two neighbor have same IP address? No chance. So this is the sequence in which the route selection decision process undergoes. Based on this, the path is determined. Yeah. So that brings us to the end of this chapter. We have two more chapters related to attribute. where we will really get into the deep dive of attribute and configuration of attribute. This is just an introduction, but it is a very important. It's not just an introduction. It is the most important introduction to the BGP's attribute. And the following two chapters are same about attribute, but a more deep dive with a case study. Yep. I'll